Okay, so this is a video on the laws of indices. So the first four I have here, the four basic ones, okay? You still need to use these, but you normally will look like you'll have harder numbers involved or you'll have fractions involved, okay? So with the first one, if we've got any number or any letter to the power and you'd multiply them, all you need to do is add your powers. So this first one would just be a to the m plus n. For example, if I had x to the power of 7 times x to the power of 4, that would be x to the power of 11, because 4 add 7 is 11. It's a little bit different if you have a number in front of it. So if you had 2x to the power of 7 times 3x to the power of 4, you need to do your 2 times 3 first. So 2 times 3 is 6, and then your 7 add your 4 is 11. Okay, so if there's a number in front, also times it. So when you're timesing, you just need to add your little powers. When you're dividing, you just subtract your little powers. So the second one, whatever numbers we have here, you just subtract. So this will be a to the m, subtract your n. It's really important to do your first one, subtract your second one, not just your biggest, subtract your smallest, because you can end up with negatives. For example, if I had x to the power of 9 divided by x to the power of 4, that would be x to the power of 5. Or if the other way around, you had x to the power of 4 divided by x to the power of 9, that would be x to the power of minus 5. So you can have minuses. I'll come on to that in a minute. With the next one, so if you have brackets involved, so if you have any number or any letter to the power of something, then in brackets to the power again, you can just multiply these two numbers. So this one would be a to the m times n. For example, if I had x to the power of 3, all of that to the power of 4, that would be x to the power of 12. So I would just do 3 times 4, which gives me 12. So sometimes, I've already got it written there. So sometimes you can have things to the power of 0. For example, if you had a dividing and you had x to the power of 5 divided by x to the power of 5, that would be x to the power of 0. And anything to the power of 0, which I've already wrote, is 1. So because essentially you would have 5 lots of x's, 2, 3, 4, 5, divided by itself. And when you divide something by itself, it just makes 1. For example, 7 divided by 7 is just 1. So all of that would just cancel out to make 1. So those are the four basic ones. So an introduction is when you're timesing, you just need to add your powers. When you're dividing, you subtract your powers. And when there's brackets, you multiply. And if anything comes out to the power of 0, that just equals 1. So I'm going to move on to a little bit harder ones now. So when we're looking at negatives, so for example in the one above, we had x to the power of 9 divided by x to the power of 5, which just gave me 1. Which gave me to the minus 4, I think it was, wasn't it? I can't remember what it was now. To the minus 5. So let's take this as an example. So we've got x to the power of 4 divided by x to the power of 9, which gave me x to the power of minus 5. Now that can simplify. So when we have negatives, there's essentially you're timesing it by decimals, because when you've got to the power of 4, that would just be 4 lots of x. But this is a negative, we've got a fraction really. So if I have anything to the power of minus 1, that is 1 over that number or that letter. So for example, if I had x to the power of minus 1, that would be 1 over x. If I have 4 to the power of minus 1, that would be 1 over 4. Sometimes your calculator works like this instead of fractions, so you need to know the difference between those. If it wasn't a 1, so if I had anything to the power of minus 2, that would be 1 over that letter squared. So if I had x to the power of minus 2, that would be 1 over x squared. If I had 4 to the power of minus 2, that would be 1 over 4 squared. And you need to simplify that then. So 4 squared is 16, so that would be 1 over 16. If I had anything to the power of minus 3, that would be 1 over that number or letter cubed. So if I had x to the power of minus 3, that's 1 over x cubed. If I had 4 to the power of minus 3, that would be 1 over 4 cubed. And don't forget, you have to work that one out just like we did with the 4 times 4 is 16. That would be over 64, because 4 times 4 times 4 is 64. It doesn't mean 4 times 3. And if you had any other number, then you just do the same. It just repeats, okay? So those are negative numbers. You can also have fractions into your powers. I've run out a bit of room here. I'm just going to zoom right in. So you can also have fractions. For example, if I had something to the power of a half, anything to the power of a half is just the square root of that. So if I had x to the power of a half, that would be the square root of x. If I had 36 to the power of a half, that would just be the square root of 36, which is 6. So anything to the power of a half means you take the square root of it. Sometimes you might not have a half, you might have a third. So if I had a third of the number, that means you take the cube root of it. So if it's just a half, you take the square root. If it's 1/3, you take the cube root. So if I had the cube root, x to the power of a third, that would be the cube root of x. If I had, I can't do 36, let's do a number that works out to a number. Let's do 8 to the power of a third, which is the cube root of 8. Cube root of 8 means what number times by itself 3 times gives me 8, and that would be 2, because 2 times 2 times 2 is 8. Again, if I had anything to the power of 1/4, this could carry on and on. That would be 4 root of a. So if I had an x to the power of 1/4, we would do 4 root of x. I almost wrote a then. Sometimes your numerator can change. So your denominator tells you basically how many roots of it you're taking. So if it's just a half, you square root of it. If it's a cube, you cube root of it, etc., etc. If I had, let's use 2/3 as an example. So 1/3 would still be the cube root of a. But because we've got a numerator of 2, that means you would then square your a. So you would do the cube root of a squared, basically. So you square your number and then take the cube root of it. If I had, let's swap them around. So if I had 3/2 into a fraction, the denominator is a 2, so that means I take the square root of it. And then I need to cube my number. So I would do a times a times a. If I had, let's do another example, so random numbers. If I had a to the power of 5/7, denominator tells you the root of it, so I would take the 7 root of a, that would be a giant number, and then I put that to the power of 5. Okay, so those are rules of indices. So we went through the first 4, went through negative, and we went through fractions. I'm going to look at some examples now on how these are manipulated, working with really hard examples. Okay, so these are off additional maths papers. The first one's off a 2011 question paper, if I remember correctly. So the first one, showing all your workings, find the value of each of the following. So the first one, we've got 36 to the power of minus a half times 125 to the power of 1/3. So this involves negative and fractions together. So if we just start with 36, let's take them one at a time. So if I got 36 to the power of minus a half, I'm going to leave the half a minute. Minus means it's 1 over. So that is the same as 1, I'm just going to zoom in, 1 over 36 to the power of a half. Now I'm actually going to work out 36 to the power of a half. Don't forget, anything to the power of half is a square root. So this is 1 over the square root of 36. I know the square root of 36. The square root of 36 is just 6. So that's 1 over 6. So I've got an answer. I'm now going to do the 125 to the 1/3. Now if anything to the power of half is the square root, anything to the power to the 1/3 is the cube root. So this means the cube root of 125. So you need to know what number times by itself 3 times is 125, and it is 5. So 36 to the power of half is just 1/6, and 125 to the 1/3 is just 5. Just need to multiply these now. So 1/6 times 5 is just 5/6. So I just do the tops times the bottom. So I would do 5 times 1 divided by 6. So that's the answer to the first one. Next one, if I had 49 to the power of a half, and then all of that to the power of -2. Now, don't forget, you could do this a number of different ways. I'm going to try what I think is the easiest way. When they're in brackets, you can just multiply these top two, these powers. So a half times -2 is going to be minus 49. So we're basically doing 1/2 times -2. So when I want half of 2, that's just 1. So this would be 49 to the power of -1. When I'm doing to the power of -1, that's just 1 over the number. So it's 1 over 49 is our answer. You could have done that a different way, but I find that the quickest, less workings. Okay, next one. Simplify each of the following. So I'm just going to zoom right into this first one. Hopefully, oh, that's really blurry. I'm going to keep it zoomed out actually. Okay, I'm going to take the first one. Simplify each of the following. So let's just take the top numbers first. So I've got 6x to the 3 over 2 times 5x to the 1 over 4. I'm just going to leave the bottom for a minute. So when I'm multiplying, like I said earlier, you're going to have to multiply the numbers first. So I need to do 6 times the 5, which is 30. When I'm multiplying, I add my powers. So this is going to be to the power of 3 over 2, add 1 over 4. When you are adding fractions, 3 over 2, add 1 over 4, the denominators need to be the same. So if I just double this one, my denominators will be the same. So this is the same as 6 over 4, add 1 over 4, which is 7 over 4. So I've got 7 over 4. Ooh, just zoomed out there. It's not working. So I got 3 over 2, doubled to get 6 over 4, add my 1/4 to get 7 over 4. So my top number, oh I haven't simplified, is 30x to the power of 7 over 4. I'm going to do my denominator. So I've got, so this will be over x to the power of 5, and then all of that to the power of 1 over 4. Now, when we have brackets, don't forget we must times them. So I'm going to do 5 times 1/4. So I want to do 5 times 1/4. So I'm going to keep the denominator the same. So that's 30x to the 7 over 4. That looks like 14 there, doesn't it? And then I want to do x to the power of 5 times 1/4. So that would just be x to the 5 over 4. So I've got 30x to the 7 over 4. Ooh, this is really horrible writing. To the power of x to the 5 over 4. Now these are dividing. So when I'm dividing, I subtract my powers. So I want to subtract these two powers. Now you also do the same to the numbers. So there is an invisible 1 here. 30 divided by 1 is just 30. So this would be 30 to the power of 7 over 4. Take away 5 over 4. Luckily the denominator is already the same. 7 take away 5 is just 2. So this will be 30x to the 2 over 4, which is the same as 30x to the half. That doesn't mean the square root of 30x. Just leave it like that, because technically that means 30 times the square root of x. But I would just leave it like that. Okay, I've used a lot of space and kind of cramped that in for that top one. I'll try not to do the same for the bottom one. Okay, I'm just gonna, there you go, got a bit more room now. So I've got next one. This is a little bit different, okay? So we've got 3y to the power of 1/5 plus 2y to the power of 6/5 all over 5 to the y 1/5. What I want to do with this, I want to simplify it. Now I've got a y and I've got the denominators are all 5s. So if I factorise out y to the power of 1/5, I should, from the top, I should be able to then cancel it out with this one. So whatever this is, I basically want to take that outside of the top bracket so I can cancel them out. So if I factorise the denominator, so if I take out y to the power of 1/5, y to the power of 1/5 times what is 3y to the 1/5, that's just 3. And then I've got my 2. And with this, because I've taken out 1/5, I would just be left with 5/5, and 5/5 is just 1. Okay, so that's just there. And if I keep the bottom the same, 5 to the 1, y to the 1/5, these then can cancel out because they're the same. I can basically get rid of them. So essentially, that simplifies to 3 plus 2y over 5. So factorised out y to the power of 1/5. I'll do another example like that in a minute. Okay. Let's go on to this next one. I can't remember which paper it is. I think it's of 2016's paper. Again, additional maths paper, and I don't have much room. So work out, without using a calculator, find the value of 12. I'm going to say that is, what do you reckon, that's 3 or 2? I'm hoping I'm going to change it to a 1. I don't know though. Let's hope it's a 1. If it doesn't work, it's probably not 1. Right, so showing all my workings like I did above. They're in a bracket, so I'm going to multiply these two. A half times 4 is just 2. Yeah, it's going to work. So that's the same as 12 to the power of 2, which is 12 squared, 144. I feel like that was too easy. Maybe, is it 1 mark? Yes, 1 mark, okay. Next one, showing all your workings, simplify each of the following. Just like the one above, I'm going to take these separately. I know it's very blurry, but I need to zoom in to have enough of it. So the top ones, I want to do 5 times my 4, which is 20. When I'm multiplying, I just add my powers. So I want to do 5/8, add 3/8, which is 8/8. So that's just 1. So I'm going to leave that like that. Well, I'll write 8/8, and then I'll simply cross it out. And then all of this would be divided by x to the power of 2/3. So with this, we've got 1. So we want to divide now. So there's an invisible 1 here. So we've got 20 divided by 1 is just 20. And then we take our x and we take away. So we would do our 1, which would be 8 divided by 8. Take away our 2/3. So this is essentially 20x. 1 take away 2/3 would just leave you with 1/3. And again, don't change that into the cube root of x. You could if you wanted to, but I would leave it like that. Alright, the next one. We've got 6x to the 1/4 plus 3x to the 3/4, take away 3x to the 1/4. Again, I'm going to take out my x to the 1/4, so because that's what this is. So if I, from the numerator, sorry. So if I factorise out x to the power of 1/4 for the top, I'd be left with 6 plus 3. So if I take out 1/4 from 3/4, that leaves me with, I've got my x to the power of 2/4, or a half, that is the same as. And the denominator stays as 3x to the 1/4. These can then cancel each other out. So our answer is 6 plus 3x. I'm going to simplify 2/4 to a half over 3. You could also divide by 3. So 6 divided by 3 is 2, so that's the same as 2 plus x to the 1/4. Again, if you want to change that to 2 plus the square root of x, that is fine, but either one is fine. I'd probably leave